All right, today we are going to look at two more. We're going to skip around a little. SAS, which stands for side angle side congruence theorem. And we're going to look at HL, which stands for hypotenuse leg. So let's go ahead and open up let me turn this paper over so it's not interfering. Let's open up the second one down. We're going to be on the SAS one. So let's fill the theorem language in. We'll go over the diagram. So this one says if two sides and the included if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Okay, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another, then the triangles are congruent. So what I want you to notice on the diagram, my two sides, I've got AB and DF, and then I've got AC and DE. So the word included I like to think of as in between. So if I were to connect these two congruent sides, I am forming angle A. If I were to connect the two congruent sides, I'm forming angle D. So I like to think that it's in the middle of the two sides, meaning if I were to connect them, I would make that angle. So this is considered included. So in order for us to use this SAS, I must have the two sides and the included angle. I can't have the two sides and then angle B over here, or I can't have the two sides and angle C. And the reason for that is what we talked about earlier for SSS. If we were to construct this triangle, if I have two sides and the included angle, there's no physical way for me to construct two different size triangles. It automatically, if angle A is a fixed opening and so is angle AC, then CB has to be a fixed length in order to close the triangle. So there's no possible way to construct this. Therefore, I don't even need to check the other side and the other two angles. I also want you to notice the acronym shows that the angle is sandwiched in between the two S's or the two sides. So when I use SAS, I'm looking for a diagram where the angle is in between the two sides. Okay, similar to this. So if this is true, we then would be able to say, oops, I'm going to start with A, that triangle ABC is congruent to triangle. So D over to, I guess it's actually going to go D over to F up to E, right? Because I'm going A to B, B to C. So I like to think of it as going through a single mark, through no arc, or no mark, through two. Single, none, so D, F, E. Okay. All right. I just keep going back to SSS, hoping I wrote that right, and I think I did. Okay, so these two triangles are congruent by SAS. So we will see SAS show up in some of our work. Okay, HL. HL stands for hypotenuse leg, HL, and so the only triangle that contains a hypotenuse is a right triangle. So this, if you open up your picture, it must have a right triangle, and then we're going to have the hypotenuse in one leg. Okay, so let's fill this in. If the hypotenuse is the first word, okay, if the hypotenuse and a leg of a right triangle, I'm going to underline the word right because that's kind of my third element here. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg, so I'm going to repeat those two words. And a leg, of a second right triangle, then the two triangles are congruent. All right, so diagram. Step 1, make sure I have a right triangle. Step 2, I've got the hypotenuse. Now the hypotenuse is always across or opposite your diagram, your right angle in your triangle. All right, so that's how you know you have the hypotenuse. And it's got to be a corresponding leg. So see how AB corresponds to ED? I would not be able to use HL if it was AB and FE over here. It has to be the same leg. So I am going to write here that I have triangle ABC is congruent to triangle DEF. Okay, so single tick mark over the right angle up to C, single tick mark over to the right angle up to F. Okay, so we are going to look at the next section in our notes that deals with SAS and HL, and we'll still maybe see some SSS come in. So we're kind of building our list of theorems here. We've got SSS, we have SAS and HL. So really let the acronym help you find the sides or angles that you're trying to use to prove the triangles are congruent. Okay, I'm going to stop this video, and then if you want to go on to the next video, we'll go through the examples in the notes.